Thank you very much. So first, I'd like to say I basically agree number-wise with the two previous speakers. Make it in a nutshell. Mike Rogers told us that non-OPEC would peak or plateau at 60 million barrels per day, plus or minus, let's say, 5%. I agree. On OPEC, technically, if there were no political constraint, could go probably up to 40 maximum, but probably they will never reach that for other reasons, and therefore the peak or plateau for the world, something maximum 100, probably a little below. And the date for that, around 220. To me, it's a delight to hear that, because when I published my first paper on the subject, and I was invited by Colin Campbell to Uppsala, I had put the peak in 220 at 100 million barrels per day. So, fine. Now, I also basically agree with the approach of Ray Leonard. What is he told us? I think it should be systematically used. What are the three sources of supply we have as additional supply? One, result of new exploration. Here, I agree with his conclusion that USGS with their 700 million barrels per day are probably over-optimistic. I would be a little less pessimistic than him and say put it in a ballpark figure at 500. But that doesn't change anything to the peak. Second source, improving the recovery rate. Here, we have uncertainty where we are today, where we think we are, let's say, at 35%, and we could increase to 45%. I take the numbers from Ray. I think we have an uncertainty of something like 10% on the present figure and obviously on the future. But let's say a possibility to increase by 10% is probably feasible. Difficult, but feasible. That's far below, let's say, what some other circles like IFP or Schlumberger are telling us. But to me, that's a realistic figure. Third source of additional oil, non-conventional. Here, I also agree basically with the figures which were given, and my view is that in 20 years' time, 225 could reach, in the best case, 15 million barrels per day. That's not going to change the world, and that's after the peak. So the main role of these non-conventional, it is slow down the decline, is not to move the peak. All this being said as an introduction, I wanted today to change my subject instead of peak gas and speak on something which is new, I think. I haven't seen any paper or any book, obviously, on what could be the symbiosis between nuclear and our industry. As an introduction, I'll come back briefly on something that everybody knows, the major constraint facing the oil and gas industry. The peak, the climate change. Then, a historical view of the relationship between the oil and gas and nuclear industries, seen from the IOC, seen from the NOCs. Then, a technical view of this relationship on upstream, downstream, and transportation. Last, what are the resulting long-term changes in the world energy mix? Can we have, thanks to nuclear, a way to, let's say, not avoid the crisis, it's too late, but to find a way out which is not a regression of mankind. So, I don't come back on this graph, which is well known, but it's the various views on the peak as they were a few years ago. And the red one was my publication of 1998, 220 and 100 million barrels per day. I don't want to come back on that. It's the main subject of the conference. I'll be a little more spend a little more time on that one, which summarize some views. And I must say, it took us years and years of battle in France to come to a consensus among our small little group of people who know the subject. We came in this consensus in June 2006, and this consensus happened to be PFC figures. So PFC, thanks you for joining the French club. Total, Thierry Desmarais said around 220, around 100 million barrels per day. So that were my 1998 figures. At the time I was working for him, he didn't believe at all what I was doing. ASPO, more or less, ASPO France, more or less the same figures. IFP, more or less the same. So at least we have a small club. But we are a minority vis-à-vis the rest of the industry, which consider that the peak oil is not reserve-related, but a political problem. Insufficient investment, restrictive policies about investment by OPEC country, Russia and Mexico. Here I quote my sources. Exxon, they launched an ad campaign in June 2006, no sign of peak oil. If you haven't seen the ads, they are nice for the memory in the future. Aramco, you can guess the same message. Eni, Maugeri, I know him, is head of strategy, no foreseeable oil peak. BP, John Brown, no reserve problem. Mike Lynch, above 120. USGS, DOE, EIA. Well, EIA is interesting because in June 2007, they changed completely their tack. They knew they were wrong. And instead of recognizing frankly, they started a very complex turnaround to explain us that, in fact, the fire was in the house. Now, I come back to the second constraint, climate change. Always come back to basics. Two graphs only. Here you have the natural contribution to greenhouse. You see, for 70% it's water, either in the form of vapor for 25%, clouds 15%, the rest 30%. And that gives us, at the surface of the Earth, an additional 155 watts per square meter. And that can be perfectly calculated. It's not rocket science, in fact. What do we add, mankind, entropy? Is only 2.8 watts per square meter. And here you have the composition. 53% of that is due to CO2 and the rest. So I don't want to, it's not my subject, but these things should be known. It's a marginal input, but these marginal change the balance. Second, which I think everyone should know, and apparently still it has not gone through, except that the upper one is in the Al Gore film. Look, on the last 15 years, from 1992 to 2006, the change of carbon dioxide in atmosphere in ppm and the change of oxygen. You see, it's a combustion. We are burning the fossil fuels. And the accuracy is 1 party per million. We have an absolute accuracy on this measurement. There's no doubt. So people who have doubts on the phenomenon, I find it as extraordinary. You can have doubts on the consequence, on the modelization of the future, but on what's happening, you have no doubts. You can even see the season each year. So, what has all that to do with nuclear? Let's come first to the historical view of oil and gas. You see that in the 50s and 60s, something which has been completely forgotten is that the oil industry started to be involved on a large scale. Exxon invested in the full cycle: mining, fuel fabrication, enrichment, reprocessing. Shell invested also at a lower level, and Agip, they built the first nuclear plant in Italy. It was an oil company. In the 70s and 80s, after the shocks, a renewal of interest of our industry for the nuclear, but practically limited to the upstream, to the mining. And here you see in the mining, Exxon, Occidental, Elf, Total, and well, in fact, at least more than 10 oil companies acquired interest in uranium. only one company was bold enough to go in reactors. That was Shell. They bought in General Atomics and developed with them an HTGR reactor, which received an 8 letter of intent, so it was a real project. They lost $2 billion. They closed the file, never reopened it again. But we must know that. Today, only one oil company has kept a small interest and announced repeatedly, once in 2006 and once this year, their intention to look at nuclear again. It's Total. And other IOC keep totally silent. I guess they must be thinking and brainstorming. If they are not, that's extremely worrying. Now, the oil-producing countries. Up to recently, most oil-producing countries looked at nuclear energy as a competitor or a threat. You have hundreds of quotations on that subject. One exception, Iran. Under the Shah, the regime launched a comprehensive nuclear program from uranium exploration to enrichment. In fact, they entered Eurodif, and they are still legally a shareholder, by the way. And electricity generation, they decided 2 major plants, including Bushehr, which is now famous to anyone. These plans were officially revived in the recent years, but in the worst possible condition vis-à-vis the international community, with undeclared programs. They've been cheating their own commitments to the International Nuclear Agency, IAEA, international threats, and all the rest. Recently, I would say the last year practically, a number of oil-producing countries have expressed interest in looking at nuclear. Algeria, practically all Arabic Peninsula states, Libya, Indonesia. So this recent interest is focused on 2 objectives, electricity and desalination. You know, most producing countries now desalinate on a large scale, and that consumes a lot of energy. Now, if we try to brainstorm on the future, how could the 2 industries complement each other? First, upstream. Upstream, nuclear industry has 3 potential roles: providing electricity, providing steam, providing hydrogen without CO2 emission. And that's a huge difference with all the present solutions to these 3 problems. An example, you can use it for steam injection in conventional heavy crude oils. If you take a field like Duri in Sumatra, you find it at the size for a sizable, the steam injection, the present one, is absolutely in line in terms of power required with a large nuclear reactor. For ultra-heavy oil sand and tar sands, clearly, both for the steam-assisted gravity drainage and the upgrading, nuclear would fit in nicely. When that was proposed 2 years ago by Total in Canada, and that has been an idea I pushed forward when I was still with them, it was horribly received by the Canadian administration. They say, shut up, and obviously the company had to shut up. And they announced, 3 months ago, that they were planning 2 nuclear reactors for SAGD in Athabasca. That is an official Canadian announcement. So it's no more a dream, it's becoming something in the pipeline. Shale oil production, that's even a much more tricky one. Eh? But you know that Shell is working on an electrical process, and the other classical process, which look like a cement factory, and you just a kiln and you burn the stuff to pyrolysis, both could completely change their CO2 emission balance by using nuclear. So, public announcement, I put it. Therefore, the nuclear steam, nuclear electricity, nuclear hydrogen should make it possible to extend the oil reserve, to improve the recovery factors on classical oils or heavy oils, and to improve dramatically the balance, the CO2 balance of non-conventional. If you look the downstream, we have the same problem. Electricity, steam, hydrogen. If you look large refining platform or refining and petrochemical platforms, you see that they consume large quantity of these three products. Take Gulf of Mexico, take Normandy in France, Rotterdam area, or in producing areas. In Middle East, in Venezuela, in North Africa, you have large downstream platforms. If you take the one that Iran is building now just on the coast opposite to South Pass, it's absolutely huge. If you make the balance of what they will need for these three products 20 years down the road, you can put 2 nuclear reactors. So, what I'm saying that we could also combine nuclear and gas in urban heating system. Well, people are a bit afraid when you say, well, we could have an urban heating system with nuclear. I say yes, and it can be done safely, and I'll probably make a presentation a year down the road on that. Because you have a lot of things to brainstorm. So we could probably decrease the CO2 emission of our industries, our activities, by integrating the three forms of nuclear. Now, transportation. How much time? Oh, okay. So, transportation is clearly the most difficult problem to solve. Because most people tell you, well, what do you do with nuclear? Nothing to do with transportation. I say, yes, it has everything to do, contrary to the appearance. But to demonstrate that, we need a step-by-step approach. First, I remember that there's a compactness, an energy compactness, and ease of use of liquid hydrocarbon that nothing can match. So, how do you do that? How do you power transportation? Is hydrogen a challenger? I presented that slide in a previous ASPO meeting. Here is the energy compactness of the various things you could put in a mobile automotive vehicle. It's expressed in the both important, let's say, concepts, which are compactness in massive compactness and compactness in volumic compactness, put on the same graph. So you have kilowatt per kilo and kilowatt per liter. You see that all the alternatives to liquid hydrocarbon are totally out with what you achieve with the present system. So that's a very, very strong message. When you see hydrogen, whatever form you take, whether you take it in a hyper pressure at 100 bars, whether you take it in a hydrates combined, or any other form, carbon nanotube, whatever, you always have 95% of bulk idle stuff to contain the system for 5% which contain the energy. And that's a killing factor. And people in the hydrogen industry refuse to just recognize the obvious. So, in nature, we have only two massive sources of hydrogen. We don't have hydrogen in nature. We have hydrocarbon and we have water. So nuclear power or renewable energy are the only potential massive sources of hydrogen for the long term. The rest is absolutely what we call in French shadok. Doesn't make sense. Hydrogen is a very poor energy vector, contrary to what was said in some famous books a few years ago. Its transportation costs are 10 times those of liquid hydrocarbons per unit of energy. And this is fundamental thermodynamics. That cannot change with technical progress. Thermodynamics, they are there. Can't go around them. So the factor 10, it was factor 10 50 years ago, it will be a factor of 10 times 50 years down the road. If you forget that, so not only hydrogen is a very poor medium in the automobile, it's a very poor medium as a logistic, let's say, way to carry energy. So, if one produces hydrogen and want to carry the energy. The logic is to attach carbon atoms to create new hydrocarbons molecule. You reinvent the wheel. Those molecules, then they become efficient energy vectors. They have excellent storage property for mobile application. So the future of hydrogen is therefore the production of synthetic hydrocarbons, totally or partially synthetics. I will maybe say a few words on that. The fact that you produce such hydrogen from nuclear, either through electrolysis or thermochemical process, is a secondary issue. It will take time to compare the two avenues, but one we master today, and the other we don't. So, in the first phase, electrolytic processes will make it possible to start the nuclear hydrogen industry as soon as it becomes economically competitive. Aha, what does that mean? When do the cost curve of hydrogen produced from either methane reforming or POX, partial oxidation of heavy stuff, they cross with the nuclear hydrogen curve? To me, it's rather soon, because it's linked to the peak. With the peak, you will have two things on the price effect. You will have a short term, when I say short term, a decade price effect, which will be dramatic, $200, $300 per barrel. Then a longer term, where the substitution, in particular those I'm explaining, will play their part, and then you have probably a long-term equilibrium around 100. But after, much higher prices, which will have dramatic effect on the economy. So, to determine the cost curve, you must not only have this scenario of the oil and gas price, you must have in mind a scenario for the CO2 emission cost. And here, my view is that we are totally off mark. Today, when you read papers on the subject, they say, well, $20 to $50 per ton of CO2 as an emission cost will solve the problem. My belief is that this is wrong, and probably wrong by a factor of 10 times. I would put 200 to 500 as more likely. Now, if you add something in between the official view, my view, to the cost of production of the fossil fuels, you see that the two cost curves, the one from atomic nuclear hydrogen and the one from hydrogen with the present process, they could cross very soon. Now, what markets for that hydrogen? It has a much higher economic value today for its chemical uses, refining, petrochemicals, chemicals, that as an energy carrier. And I told you an energy carrier is a poor one. So the ratio of value is from 1 to 2, from 1 to 10, depending how you carry the calculation of the case and so on. As a consequence, the first markets will use nuclear hydrogen, which will use nuclear hydrogen, are the same markets as those utilizing hydrogen today. Upgrading units in refinery, conversion of heavy fraction, upgrading of Athabasca or Orinoco stuff, desulfurization, hydrotreating, and so on. Transportation utilization would remain marginal. You can always make a little fleet of buses if you want to appear as green, because obviously it's not green at all. It's a basically illogical proposition for automobile. Aviation market could develop. It's a different issue, because in a plane you don't need to have a shock-proof container system. You can have a very, very light container system, and because it has a high energy density, massive energy density, could make sense for aviation on a very long term. Now, synthetics. What role could play this nuclear hydrogen in synthetics? If you look in biofuels, today the weakness of this biofuel is that in most places, let's say Europe or the US, the net output per hectare is very low. 1 ton equivalent oil, 2 at the maximum, 3 in very, very, very specific condition. It's much better, let's say, if you do the same calculation in Brazil for biogasoline, ethanol, or if you do it in Malaysia with palm oil. But I speak of the rich countries. They are not well placed for biofuels, but if you add to the biofuel process some heat, non-CO2 emitting, coming from nuclear, and some hydrogen, you can change the balance deeply. And then you can have a much larger production with a lower cost and much lower CO2 emission. As far as I know, nobody has looked at. If you look the other syn fuel, let's say GTL or CTL, the same would apply. If you take a Fischer-Tropsch loop and you inject heat from outside, and if you inject hydrogen from outside, non-CO2 emitting, you change the balance. What do I call new synthetics? It's synthetics which do not exist today. The two other families, they exist, you can improve them. New synthetics, you directly produce hydrogen and attach carbon to it. I proposed that 3 years ago in a paper. So here is a long-term outlook. I'm not going to, question of time, to go in detail in that, where you see the emergence of nuclear in two forms in the transport system. That is just to show it's sustainable. And here is the conclusion. On energy ground transportation today, 80%, 98% is oil and gas. 1% is nuclear. When you take a train in France, it's 80% nuclear. And 1% is the rest. With the type of scenario I've suggested, we could have complete change, and nuclear, by the end of the century, would be more than half. With two inputs, one or three inputs. Plug-in hybrids. Plug-in hybrids is an absolute major key for the future because it's a good complement to nuclear. You recharge at night when the load factor is below, so the nuclear electricity is marginally free or nearly free, depending on the country. It's free in France. That's one input, and I will never insist too much that plug-in hybrids are key to the future. And that allows to extend the life duration of the combustion engine. Second, for specific usage, because the mileage will remain limited, electric cars, even with lithium-ion batteries, there are limitations. And the third, the new synthetics. So if you combine all that, you see that nuclear can become a major contributor to the transport problem, which today is not in a good shape. Well, I skipped the air transport. Jeremy, how much time? 0? Okay, so I'll skip the world balance. You can find that in the book which is here, the cost of the various electricity. I just go to the conclusion. There are 2 pages of conclusion. Oil and gas will still be produced beyond the end of the 21st century. The paradox is that it will be the golden age of the oil and gas industries. It will also be the golden age of nuclear all along this century. A technical and economic marriage between the oil industry and the nuclear industry will develop all along the century as these industries will become more and more complementary. This marriage will deeply modify the world liquid hydrocarbon production profile after peak oil as occurred. ASPO could contribute to study this new perspective. And if you want to know more about nuclear and how it could marry, you buy the book which is over there. Thank you very much.